Hello, my name is Elizabeth Martinez, and today I will be talking about the impact of oil spills, specifically the impact of the Deepwater Horizon oil spill. This topic is interesting to me because, according to the U.S. National Oceanic and Atmospheric Administration, otherwise known as NOAA, 137 oil spills occurred in 2018. So it's indicating how frequent oil spills occur. However, the media does not always inform us about the quantity of oil spills that happen every year. So I believe that it is important to know how this is affecting not only the ecosystem, but us as well. So now I will be going over the outline for today's presentation. First, I will be giving you some background on Deepwater Horizon, the oil rig. Then we will discuss why being informed about oil spills and their impact matters. Afterward, we will go over how oil spills affect humans, as well as go over how oil spills affect marine animals. And furthermore, we will be going over a pre and post impact study about changes that occurred in reef fish communities due to the Deepwater Horizon oil spill. And lastly, we will be going over a brief synopsis on the four most important takeaways from this presentation. So now for some background on Deepwater Horizon. So Deepwater Horizon was an ultra deepwater semi-submersible offshore drilling rig. It was owned by Transocean, which is an American company, and it's the world's largest offshore drilling contractor. It was built by Hyundai Heavy Industries in South Korea, and Deepwater Horizon was leased to BP from 2001 until 2013. In 2009, Deepwater Horizon drilled the deepest oil well in history. It measured about 35,050 feet in vertical depth in the Tiber oil fields at Keithley Canyon in the Gulf of Mexico, and it was in 4,132 feet of water. On April 20th, in 2010, there was drilling going on at the Macondo Prospect, which is located at the Mississippi Canyon, when an explosion occurred. This ultimately led to cause 11 of the crewmen working on the prospect to die. So the fire was not able to be put out, which it was reported that there was a big fire that was able to be seen from 40 miles away. So because of the magnitude of the fire, it was not able to be put out. And so 2 days later, on April 22nd, the Deepwater Horizon ended up sinking. The well was leaking tons of oil at the seabed, causing what would be known as the largest marine oil spill in history. So the oil spill continued until July 15, which is about 89 days, and they were able to close it by a cap. From there, NOAA established the Gulf Spill Restoration Project to help protect and restore the coastlines from the damage done by the Deepwater Horizon oil. So why is this important and why should you care? It is important to be informed about oil spills as they can have significant consequences on habitats, ecosystems, animals, and humans. For one thing, oil spills have significant damages on ecosystems, particularly coastal marshes. The Deepwater Horizon oil spill affected nearly 1,105 kilometers of coastal marshes, and oil can affect vegetation through many different ways. This includes direct contact and soil contamination, The degree to which vegetation is impaired by oil depends on different factors. These factors include the degree of oil weathering, seasonality of exposure, soil type, and the degree of oil coverage. The effect of oil on the soil and vegetation caused marshes to lose their ability to stabilize shorelines by decreasing the vegetation and damaging the root structures. It was reported that effects of oil were noted along the marsh edges with fast decreases in soil PAH levels. PAH levels are the levels of polycyclic aromatic hydrocarbons, which are cancer-causing chemicals. These compounds are also mutagenic and ranked 9th among chemical compounds most threatening to humans. The oiled sites had an average of 82% oil residue on the sediment surface and polycyclic aromatic hydrocarbon levels that were 100 times higher than sites that were unoiled. It was concluded that oil sites experienced twice the erosion rate of unoiled sites, and additionally, animals also got affected by oil spills. An example of this are birds. So birds are the poster child of oil spills. They are usually depicted covered in oil. And of course, the oil coating the bird's feathers can be deadly. Not only does it render them incapable of flying, but it also messes with their natural waterproofing and insulation. So it makes them vulnerable to hypothermia and overheating. However, like if the oil coating is, it's not the only way birds are affected, because, for example, the Deepwater Horizon oil spill occurred during mating and nesting seasons of many birds and other marine species. So this affected breeding, and additionally, oil spills can disrupt migratory patterns by contamination of areas in where migratory or migrating birds normally stop at. So furthermore, oil spills can also affect fisheries, and it causes massive die-off of fish and shellfish. With contaminated waters and decreased fish populations, fisheries are not able to catch as many fish, thus lowering the amount of yield. And this has an indirect effect on humans, since food production will be low and can cause a shortage of fish and other seafood, which will in turn drive prices up on such items. Effects oil spills have on humans. A lot of people worked to clean up the oil spill, and many of the individuals that worked on the Deepwater Horizon oil spill were comprised of oil industry workers, coast guards, government personnel, fishermen, and volunteers. These people were exposed to toxins and stressors. There were large quantities of oil that was burned, which generated many potential harmful air pollutants. And these chemicals include hydrocarbons, benzene, toluene, ethylbenzene, hexane, etc. And as mentioned before, hydrocarbons are carcinogens. So due to the magnitude of the spill, much of the air during the burning of the oil was filled with such chemicals. This increased the risk of individuals working on the spill to later develop problems, especially if they worked for a long period of time on the oil spill. Depending on what task or job the individual had, they were exposed to chemicals associated with crude oil dispersants and oil combustion. Many studies have suggested respiratory symptoms, which include but are not limited to coughing and shortness of breath. Other symptoms of individuals that worked on the oil spill include itchy eyes, nausea and vomiting, dizziness, headaches, and dermatological problems. And dermatological problems are just issues with the skin. So additionally, it is also suggested that Gulf Coast residents may have been doubly exposed to such chemicals because they could have encountered the same chemicals and physical exposure as OSRC workers, which stand for Oil Spill Response and Cleanup Workers. And the majority of the people who worked on the ORSC team were residents of the most highly affected counties on the Gulf. So this means that not only were they exposed to these chemicals while working on the oil spill, but they were also exposed to the chemicals due to living on the coast. So not only does the oil spill directly affect humans in ways related to health, but also in socioeconomic problems. Due to the oil spill, many individuals that normally worked with anything having to do with the ocean were out of jobs. For example, many fishermen were temporarily out of work due to not being able to fish in contaminated waters. And the oil spill also affected tourism, thus generating less revenue. This can cause psychological stressors on individuals due to not being able to work, yet still having to find a way to make ends meet. It was suggested that job loss and income reduction for many people could possibly also lead to emotional distress, domestic violence, and substance abuse. The effects on marine life. The ozone helps the Earth by absorbing UV rays. However, ongoing climate change, such as increase in chlorofluorocarbons, are causing a decline in the ozone layer. The chemicals released when the oil was burned enter the atmosphere and react with other compounds that then contribute to the ozone depletion. Hence, by contributing to ozone depletion, more harmful UV rays are able to enter the atmosphere. Specifically, UVB radiation enters the atmosphere at higher quantities, and these UV rays are responsible for the damage of early developmental stages of fish, shrimp, crabs, phytoplankton, etc. Additionally, algal blooms can be formed due to oil spills. Often they are termed as red tides. Harmful algal blooms occur, and it causes major die-offs of marine animals in that area. So in turn, it messes with the food web as many individuals from a certain species can die, leaving other species with a shortage of food. Now we will take a look at a pre and post impact study on Deepwater Horizon. We will be looking at changes in reef fish community structure following the Deepwater Horizon oil spill. During the time of the start of the oil spill in April until it was capped in July, 4.9 million gallons of oil was released into the Gulf of Mexico. There was a surface slick of about 40,000 kilometers squared that was produced, and 4 to 14% of that discharge was transported to the benthos by contaminated marine snow. Marine snow is an organic material that falls from the upper levels of the water column to the deep ocean. This exposed many pelagic and benthic communities to PAHs. And the community of interest in this study were reef fish communities. which are benthic ecosystems. In this study, they analyzed a time series that shows both direct and indirect effects on the Deepwater Horizon oil spill on the northern Gulf of Mexico reef fish communities. They tested whether there were significant changes that occurred in reef fish communities following the Deepwater Horizon oil spill. And furthermore, they asked if there was a significant change that occurred, and they wanted to find out whether it happened evenly across trophic guilds or if it happened more to a specific guild. They predicted that the Deepwater Horizon oil spill had significant changes in reef fish communities. So for the methods, to collect their data, they surveyed fish communities at 16 different natural reefs in the northern Gulf of Mexico by using a video array Pro 4 mini remotely operated vehicle, which is also known as an ROV. These reef communities were randomly selected from sites that were surveyed in 2008 and 2009. In total, 250 ROVs surveys were done between 2009 and 2017. The pre-Deepwater Horizon oil spill portion of the time series was made up of 26 different surveys across 11 different sites. And the ROV was equipped with 570 line camera for real-time viewing, LEDs, and other high-definition cameras in order for them to record videos of the reef fishes in their community. And then these videos were analyzed to see what fishes could be identified to the lowest taxonomic level possible. And counts were made to estimate abundance for each site that was observed. Permanova models were also computed for temporal changes in reef fish community structures after Deepwater Horizon. Changes in the community structure were also analyzed using indices of species richness and diversity. Temporal changes were also measured in density for 9 trophic guilds. Some of these included herbivores, small and large demersal browsers, carnivores, and reef planktivores. Species were assigned to guilds depending on what their diet consisted of. So let's take a look at some of the tables and figures from the study. In Figure 1, it shows a map of the northern Gulf of Mexico for Map A and a sampling region for Map B. The X and the Y axis for both of these maps represent the coordinates because it is trying to show us a location. In Map A of Figure 1, it is showing the Gulf of Mexico with the square depicting the area where the Deepwater Horizon blowout happened. And Map B is just basically a zoomed in version of the square from Map A. And it is showing us a closer look at the location of the blowout. The triangles on Map B indicate the Mississippi Canyon, while the circles indicate the natural reefs where there were surveys from 2009 till 2010. And then furthermore, the shaded areas represent the surface oil coverage in days. And so looking at Figure 1, Map B, we see that the further away the location is from the blowout, the less cumulative days that there was oil coverage. In Table 1, it shows the Permanova results and that they indicate community structure significantly differed among years. And a Permanova is a multivariate technique used to show complex data sets. And so the random effect of month with year was also significant, yet random effect of site within month was not statistically significant. For the results, Figure 2 is linked to Table 1 from the last slide, where the asterisks on Figure 2 indicate a significant pairwise difference between pre and post Deepwater Horizon time points gathered from subtable. And in Figure 2, it is showing the total fish density and community indices. So in Figure 2a, the x-axis is indicating the year, while the y-axis is showing the level of species richness. In 2010, we see a significant decline in species richness. It went from about 18 species per site to 10 species per site following the Deepwater Horizon oil spill. In Figure 2b, the x-axis is showing the year and the y-axis shows the diversity. And then from looking at the graph, we see that there is a decline in species diversity after pre-Deepwater Horizon, with it being about 1.6 before the oil spill and never reaching that diversity again throughout the rest of the years that were sampled. Additionally, in Figure 2c, there is also a decline in evenness following the oil spill. Again, the x-axis represents the years, while the y-axis represents the evenness. From the years surveyed, the highest evenness reached was about 0.6 in pre-Deepwater Horizon. In Figure 2d, the y-axis represents the fish density and the x-axis the years. So although the decrease in fish density in 2010 was not significant, it was still substantial compared to pre-Deepwater Horizon. Taking a look at Figure 3, it represents the standardized trophic gill densities. So the x-axis represents the year, while the y-axis represents the fish density. And then each graph is labeled corresponding to the gill that it is representing. So in all 8 trophic gills, the density following the Deepwater Horizon declined. Out of the 8 gills, 4 of them reached their lowest density in 2010. And the densities of herbivores declined by 96%, small dermal browsers by 87%, and small demersal invertebrates by 82%. Reef planktivore densities, on the other hand, remained unchanged following the Deepwater Horizon, as they don't depend on benthic foraging. So these results indicate that reef fish communities did show clear signs of negative impact following the oil spill, with significant shifts in the structure of the community and the decline of the species richness, evenness, diversity, and total fish density. Now we will take a look at the take-home messages from today's presentation. So first of all, oil spills are harmful to ecosystems for numerous reasons. This includes the erosion of coastal areas, ozone depletion, and an increase of die-off in animals. Also, marine animals are drastically affected by oil spills. Their habitats are destroyed, food webs and trophic levels are getting messed up, and their species abundance is declining. Additionally, oil spills directly and indirectly affect humans. They directly affect us by causing shortages of seafood, so there is less food to feed populations. It directly affects humans due to all the harmful chemicals and that are released and breathed in, which later can cause respiratory issues. And lastly, due to the problems that oil rigs cause, as seen in this presentation, it is better if we were to move away from using this type of energy and switch to using renewable energy, because not only is it better for the environment, but it is also better for our health. Thank you for watching my presentation. I hope you enjoyed it.